So, in today's discussion, we will be talking about projectile motion. I'm gonna to talk about the very important formulas from projectile motion. So, what is the projectile? Projectile is any object that is thrown with some initial velocity v naught and a certain angle with x-axis, and its motion will be determined by the action of gravity and air resistance only. That is the definition of projectile. Okay, so while deriving the projectile motion, these formulas related to the projectile motion, we ignore air resistance. So only the flare that determines the path of the projectile motion trajectory is the gravity. Okay, so look at here. First of all, what determines the position and the velocity of the projectile? Look at here. Let us consider a project coordinate Cartesian coordinate system, x and y axis here. If you project some object from here with some initial velocity v naught, making angle theta with positive x-axis, the path followed by projectile is like this. This path is said to be trajectory. The path followed by the projectile is said to be trajectory. Okay, so most important thing that we have to find out is the positions, x position and y position. Okay, and then velocity. That's what we need to know about the projectile motion. That is the first and foremost thing we must know. Where is the particle, where is the projectile at certain point of time, and what is its velocity? Those are the very important points, right? In daily life, we have to launch some missile or something else in daily activities. So studying the projectile motion is very important. It is closely related to our daily lives, right? So let us begin with first formula. First one, you can look at here, which is the x. This gives you the x position, where the x position of the projectile at certain point of time t. Okay, so this x coordinate at certain point of time after launching the projectile is given by the initial velocity of the projectile when time t is equal to 0. That is the initial velocity at the beginning of the projectile v naught. Cos of the theta, this angle theta, multiplied by time. So this expression gives you the x component or x coordinate of the projectile motion. Okay, the second important thing is the y component, y coordinate of the projectile motion, which is equal to v naught, that is initial velocity at time t naught, sine theta t, that is time, minus half gt squared. Look at here, why we have gt square, half gt square in second equation in y component. Why not in x component? Because in x component, velocity remains constant. Remember here, bx is equal to constant k along y-axis. But velocity along x-axis is changing. Velocity along x-axis is changing. That's why we call velocity remains constant in projectile motion along x-axis, and acceleration remains constant along y-axis, right? So that's why the position of the projectile depends on the initial velocity, the angle at which projectile is launched, and also acceleration due to gravity. Okay, so that's why this term is here. When you throw up some objects like this, acceleration is pulling downwards, but that effect is absent along x-axis, right? There is nothing pulling towards this direction. That's why velocity remains constant, acceleration is zero, right? So after you know the x component and y component of the projectile, you can find the position. You know that, right? If you have x and y component, you can find the vector, which is position vector, right? X squared plus y squared. So these are two important things. Once you know the position, our goal is to find velocities. So splitting into components, first find the x velocity. So if this is the b naught, which is the vector, right? Velocity is a vector. You can split this velocity into x component, which gives you the x velocity, b naught cos theta, p naught cos theta, right? If you complete the triangle right here, what is the cos theta? Cos theta is simply uh, uh, the base, this base, right? Bx divided by what? Longest side is b naught, right? From here, bx is equal to b naught cos theta, right? That's how we get it. Similarly, you can find the y component of the velocity, that is this component of the velocity, right? Which is b naught sine theta. Similarly, you can take the sine theta, ratio of the sine of the theta in this right angled triangle, and you will get b naught sine theta. That is the y component of the velocity. But again, along y component, y velocity, the y direction, there is the effect of acceleration due to gravity. Because of that, we have to put this term, because acceleration is there, y acceleration is there, that will affect the x velocity, right? There is something gravity is pulling down, so y velocity is changing. That's why we said along y-axis there is acceleration, right? So by, that is velocity along y-axis at certain point of time t, is given by velocity at time t equal to 0 sine of theta minus zt. Z here is acceleration due to gravity. Remember, the value of z is greater than 0. Okay, so these are most important four formulas that determines position and velocity of the projectile motion. So other than these formulas, there are few other formulas that you should know, any physics students should know. Look at here. First one is maximum height. So if you launch something, for example, launching the firework or anything that you are launching, missile or some other objects in the sports, so many things you have to launch it, right? In our daily life, daily activities, you have to throw a stone and so on and so forth. Okay, so maximum height is the maximum height attained by the projectile. Look at here, up to this point, this height is the maximum height, right? So how much height could that projectile attain with the particular initial velocity and angle that it makes with the horizontal axis, right? This theta. So this maximum height will be determined by b naught squared sine square theta. Initial velocity squared sine square theta divided by 2g. This is the formula to find the maximum height. Okay, if you know the initial velocity, you know the angle, you already know the value of z, which is 9.8, you can determine the maximum height attained by the projectile motion. Okay, second important thing is how much time the projectile will remain in the air, that is time of flight, that we call time of flight. The launching of the time from launching of the projectile to the landing back to the ground, that is the time period. Okay, the time. So time of flight denoted by t and given by 2 b naught sine theta divided by g, right? So this is another thing. The third important thing is horizontal range, how far it will land. This is the total distance from here, initial position of launch, to the final position at which the projectile is landing. Okay, so this is given by this relationship, which is equal to b naught square sine 2 theta given by and divided by z. Look at all these equations. if you look at all these equations, starting from beginning position to all the way down here, the range, everywhere you can see initial velocity and this angle theta. So that's why there are two parameters which are very important. One is the v naught initial velocity and other is angle theta that projectile makes with positive x-axis. Okay, so if you know the v naught and the theta, acceleration due to gravity is known, that is 9.8. You can determine maximum range, horizontal range, time of flight, maximum height, velocity x component and y component, and positions x and y positions. So these are very important thing to be known for the physics major. Okay, so one more thing here, at this point velocity of the projectile will be 0, however acceleration will be negative of c. Okay, and as I already said, velocity along y-axis is changing all the time. That's why there is acceleration, but velocity along the x-axis remains constant. Okay, so one more thing that I have to tell before ending this video is at what angle range will be maximum. At what angle range will be maximum? This will be maximum with same initial velocity and angle. For that, sine theta, sine 2 theta should be 1, right? Maximum value of sine theta is 1. So from here to theta will be 1 only if 2 theta is 90 degree. So theta is equal to 90 divided by 2, it is 45 degree. Okay, so if you launch a projectile making an angle 45 degree, it will cover maximum horizontal range. So the maximum horizontal range is given by, you can just erase this portion, right? B naught square divided by z, because sine 2 theta will be 1 when range is maximum.